share my screen. Okay. So okay, so welcome everyone to today's lab session. Okay, actually it's still 2 more minutes before we start. So yeah, you can see there's a book. There is the AMC book, and for all the questions that are going to be shown in this live session, they are from this book. So I can show you like a page from this book. For example, so you can see this is a very beautiful page of the book, right? So it's talk about prism and pyramids. So it's about three-dimensional geometry. Okay, and the good part about this book is that when you are actually trying to solve a problem, you can always go to the first part, which is the example and summary. So you know that, okay, these are the knowledge, these are the things I'm going to know and later apply to the problem solving. It's kind of give you some reference in the direction, right? Makes the problem solving session easier. Also, another part about this book is that, so usually you'll see in the 100 tricky AMC problems, you'll see things like Warmup in AMC 8, and also there should be something called exit ticket, okay? Right here, exit ticket. So these problems are based on the same knowledge. They will test you on the same modula, the same concepts, but they have an increasing in the difficulty level, okay? So for example, Warmup is just to help you get familiar with the concept. And in the real AMC problem, you are going to see a real problem from a past AMC8. Then in the exit ticket, it's basically give you a final chance to see if you fully understand all aspects of the concepts. Okay, good. So now it's 4 o'clock, and welcome everyone to today's live session. We are going to solve some AMC8 number series problems. Okay, good. Now, here comes the first problem. Let me plug in my charger. Okay, good. So let n be the greatest 5-digit number. Okay, so where's my pen? Okay, my pen's right here. Good. I will take blue. So now let's highlight the keywords. I will say n is the greatest, okay, 5-digit number whose digits have a product of 120. Then the question is, what is the sum of the digits of n? So when you see a problem like this, you will try to first do the factorization, okay? Because we're asking for product of 120. So naturally, we want to know what are the numbers that's multiplied together. So I will write the first step. I will put 1 here for first step. That's perform factorization. Okay? Okay, very good. So 120. Since it's an even number, we want to start with 2. Okay, the first divisor. Then we get 60. Same deal, 60 is still an even number. So divided by 2 again, we should get 30. Divided by 2, okay, it's no longer even. It's odd number, right? It's 15. So 15 definitely is a product of 3 and 5. So you can divide by 3, and the last number we have here is 5. So this is actually not only factorization, but prime factorization. So based on the above, we can write 120 is equals to how many 2 we have? 1, 2, 3. So 2 to the power of 3 times 3 times 5. Okay, so that's for the first step. And actually, we can still do another step of simplification. 2 to the power of 3, which is 8. Okay, so 8 times 3 times 5. Just copy it down. So this is the first step, factorization of 120. Now let's get to the second step, okay? So now, second step, I will put number 2 here, denote the second step. Let's say n is a 5-digit number, so n equals to 1, 2, 3, 4. Okay, these are 5-digit. In order to make it the greatest, we want to put the higher number to the left, right? For example, for the first digit here, this is ones, tens, hundreds, thousand. Okay, so for the 10,000th digit, we want to put a 9, right? Because 9 is the maximum, is the largest number ever possible to put on a single digit. Now, consider about 9. We need these numbers to be product, to have a product of 120. In the other words, the number appears in a digit must be a factor of 120, okay? So is 9 a factor of 120? So that's why we need the factorization step. So 9 doesn't appear among these numbers, so we know that 9 cannot be worked here, okay? So let's put a red cross next to it, so 9 is eliminated. And let's try the next largest number, which is 8, okay? Good. Okay, let me zoom out a little bit. Okay, good. So here is 8. Oh, I will keep using green, okay? So I'll do control. Good. So here we want to use green. So I will say 8. Let me put it a little bit lighter. Okay, good. So for 8, we want to see if 8 works. So 8 is large and it is actually a factor of 120, right? It appears right here. So 8, it actually works. So for the reasoning, I will say 9 is not a factor of 120, okay? That's why 9 cannot be put on the 10,000th digit. Now we have 8 here on the 10,000th digit. Let's try the next digit, which is a 1,000th digit. So 8, 3, 5. What is the next largest value we can have? It's 5, right? So again, in order to find the greatest number, we are putting those high numbers to the left, right? We're not leaving those single-digit numbers that are small to the right to be the 1st digit, to be the 10th digit. But for the thousands and 10,000 digit, we want to have numbers like 8, 9, like these, right? So 5, okay? 5 is the next largest number we have as a factor of 120. So 5 we have. Then what about the 100th digit? We want to put down 3, right? Why? Because 3 is right here and it is a factor of 120. So how about the last 2 digits? Remember, we need all these 5 numbers multiplied together to get 120. So now we already have 120. So the last 2 digits, remaining 10s and 1s digit, they must be 1, okay? So now we have our number n created. And the question is, what is the sum of the digits of n? So that should be easy because sum of digits, okay? It's just adding up the 5 numbers we have, which is 8 plus 5 plus 3 plus 1 plus 1. So that's basically 18, okay? Okay, very good. So 18 should be our answer, and that's option D. Good. Okay, let me get my phone. Okay. Now, we are ready to go to the second problem, okay? So let me get my pen ready. Okay, now for the second problem, it's an exit ticket. So it's basically going to test you on the same thing, but it will be a little bit more challenging, okay, than the real MCA problem. So let's read the question together. Let n be the greatest 5-digit number. Okay, it's the same thing exactly. So I will highlight that. We are finding the greatest 5-digit number whose digit have a product for 140. And the question is, what is the sum of the digits of n? Okay, so what is the sum? Again, asking for the sum of digit. Now, what's the first step? Always, when you see description like product of a number, you want to think reversely. Think about what are the divisors of 140, right? What are its factors? So the first step is, I would say, factorization. It's actually prime factorization, but let's just write factorization. Okay, very good. So 140, let's take a closer observation of the number. Is it even or is it odd? So definitely it's an even number. It ends with 0. So let's try the first divisor to be 2. 140 divided by 2 is 70. Again, let's divide by 2 again. Since 70 is even, Okay, so we end up with 35. 35 is 5 times 7. So let's write the number 140 into its factor form. Okay, so 140 is just 2 to the second power times 5 times 7. Okay, I read my file a little bit like 3, so I will erase that. Okay, good. Times, is my pen still in blue? Good. Times 5 times 7. Wonderful. Now we can do another step. That's rewrite 2 to the second power as 4, then times 5, then times 7. Okay, good. So that should be very enough for the first step. Let's get to the second step, okay? So for the second step, it's asking for the greatest 5-digit number. So again, let's say this number is n and the 5-digit. We can just list them, okay? That's for the 10,000, thousands, hundred, tens, unit digit, which is the ones digit. Okay, very, very good. Now, let's think about, in order to make the greatest 5-digit number, we want what? We want to put large numbers to the left, right? Put down the 10,000, put down the thousand digit numbers like 8 or 9, and put those ones and twos on the ones and tens digit. That's our strategy, right? So let's try, what is the largest digit possible to put on 10,000? Obviously it's 9, right? Let's put 9 here. So 9 needs to be a factor of 140, but 9 doesn't appear on our factorization procedure. So this indicates that 9 cannot be put on the 10,000 digit, okay? You see the reasoning behind? Test if this number is among our factorization, okay? If it's not, then 9 doesn't work. Same idea, how about 8? Okay, 8. Is 8 a factor of 140? So the factors are 4, 5, 7. 8 is not, right? So because of the same reason, since it's not among the factors, so 8 is eliminated. So 8 are gone, 9 are gone. So what's the next number we want to test? Okay, I want to test 7. So 7 is right here. It's one of the factors of 140. So we know we can put 7 here since it's already the largest possible single digit number. Okay, good. So same idea. After 7, we want to put the rest 2 factors on the digit. So we should put 4 here or 5 here. Remember, you put a larger value to the left as so you want to put the largest value as left as possible. So 4 is less than 5, so you want to put 5 first, then followed by 4. Now already we have 7 times 5 times 4, which is 140, and our product is 140. So the rest 2 numbers must be 1, okay? In order to satisfy this restriction of all digits products 140. So I will say these 2 doesn't work because they are not a factor, okay? Not a factor of 140. So we know our n is 75,411. So how to add up? It should be easy, okay? So summation, I will just say sum of digits. Sum of digits is just 7 plus 5 plus 4, then plus 1 plus 1. So that's basically 12 plus 4 is 16. 16 plus 2 is 18. Okay, so 18. I will put a box to denote that's our final answer, 18. So that's for option D of this extra ticket problem. So again, let's do a quick review of a problem like this. So the key words is product of a number. Then you think backwards, think about, okay, what are the multipliers or divisors? You do the factorization. After you identify all the factors, you are going to compare those that is possibly on the digit than those you have on the factorization, right? If they match, good. Then we're just putting the largest number to the left and in a decreasing order from left to right. If it doesn't match, then we go to the next largest number. Okay, the key thing is that the number you put on a digit according to the problem must be among those numbers as the factorization. Okay, good. So let's go to the next slide. So actually, before we move on to solve another AMC number theory problem, I think it's a good time to give a brief information session about our timeline for students preparing for the upcoming 2025 AMC exam. So as you can see, this is a timeline, and starting from June, okay, we already are into our, I think, third or fourth class of our prepare for AMC8 using past exam, the class. So for this class, the highlights is that in this class, we are going to use the real problem from past AMCA exams. One class, one exam. For example, the first class, I think the teacher went through the problems of 2009 AMC. And the second class, the class content is majorly about solving problems from 2012. The third class is 2014. So you see the ideas, right? The good part about this is that while taking this class, the students can be very familiar with the formats, the structure of the exams, and have a good expectation of what kinds of problems they are going to see when they are taking their actual exam. Okay, so that's for the AMCA prepare with past exam lesson. We have the first round, and also we have the second round. The structure, the format, the way things are covered are exactly the same for the both rounds. But for the second round, we are using problems from different years. For example, we are going to include AMCA problems from 2013 exam, from 2015 exam. So we can see it's no overlap between the two classes, okay? Okay, that's for the AMCA prepare with past exam class. In addition, in August, and in October, we will going to open the modular class. So as you all know, AMCA exam can be separated into 6 different modules. That's geometry, arithmetic, word problem, statistic probability, and number theory. Okay, so for these models, we are going to select 2 models to just open a modular focus class in August and October. So that is a very good opportunity for students who are strong at the other model but kind of need a little bit more practice or assistance in a particular model to join the class. Okay, that will be modular specific class. And in the November, December, okay, we are going to start our AR and HR class. So AR is the abbreviation for honor roll. So these classes are specifically designed for students who are aiming to achieve the honor roll in the AMC exam, okay? We're going to have 3 rounds of such class. And after that, for the HR, it's actually the counterpart of AR class. HR is basically designed for students who are aiming to achieve the honor roll. So for AR, it's achievement roll, okay? So for HR, it's the honor roll. And we also have 3 rounds of that class. And finally, before we're actually going to take the exam, okay, in January next year, we will have a DHR lesson. So DHR is specifically designed for students who are aiming for the Distinguished Honor Roll prize. So besides those classes offered, we also offer in total of 5 mock exams. So as you can see from the big picture, we have 2 rounds of prepare from past exam AMCA lesson, 2 rounds of modular class, 3 rounds of AR or HR class, and 5 rounds of mock exam. So it's highly recommended that you follow your own needs to select some classes to take. Okay, not all of them, but just select those that feel like you are in need. You feel like those will be very helpful. And here's a barcode on the right-hand side of this slide. So if you scan that, you will know more about the second round of AMCA Prepare with Past Exam class. Also, there's my WeChat ID, ThinkWebby60. Okay, you are more than welcome to add me on WeChat, and I can help you to figure out what are the classes that will be most beneficial for the students. Okay, good. Now that's enough for the information session. Let's go to the third problem of today's live stream. The third problem is a warm-up. So we're going to learn some concepts. So the question says, how many factors of 2024 have more than 3 factors? Okay, so let's read it again. It's kind of weird wording. So how many factors of 2024 have more than 3 factors? So for example, 12 has 6 factors, namely 1, 2, 3, 4, 6, and 12. Okay, so these are ones adapted from question 17. So always, since we are talking about factors, about some integers, then ideally we are going to do the factorization step, right? So our first step is find those prime factors of 2024. So I will say find prime factors of 2024. So since 2024 is an even number, we want to start by 2. So start by dividing 2, we get 1012, right? Then still an even number divided by 2 again, we should have 506. Divided by 2 for the third time, since it's even, right? We get how many? 253. So okay, take a closer look. Do you guys think 250 is a prime number? Think about that. Actually, if you write 253 as 220 plus 33, it will be very straightforward that these are not prime numbers. They are multiples of 11, okay? So their sum must be multiple of 11 as well. 253 divided by 11, we're going to have 23. And 23 is a prime number. So we end when we have a prime number, okay? Now let's just rewrite the thing. Is 2024 is equal to how many 2 we have? 1, 2, 3. So 2 to a third power times 11 times 23. So I will write 1 for the power on top. Okay, it may look a little bit weird because usually we do not write power of 1 explicitly, right? But this time I'm keeping that for some purpose. You will see it in the second step. Okay, believe me. So for the second step, let me get my pen. So here, actually, we are going to apply some formula. It's kind of important because if you know the formula, it will save you a lot of time. So I will say apply the formula. Apply formula, okay? And what is the formula? So the idea is that I will use that symbol for number, okay? So that will make me writing faster. So let me rewrite that. So the formula tells us that, okay, this is my pen. The number of positive factors of, okay, so I'm rewriting off. The number of positive factors of an integer is equal to all the exponent plus 1, okay, and then multiply together. So in this case, our integer is 2024. So this will be equal to what are the exponents of the prime factors. So for the first prime factor is 2, and then we have its power to be 3. So power and exponent are the same thing, right? So okay, we are taking 3. Then how about the second prime factor? It's 11, right? So 11 its exponent is just 1. Remember, I'm purposely writing out like the power of 11 since it's only 1 power, because in this case it will be very clear. Same idea. 23 is 23 to the first power. So exponent is just 1, okay? So we are going to add 1 to each of these exponents. Then doing what? Then multiply them all together, okay? So that will be 4 times 2 times 2. So 4 times 2 is 8. 8 times 2 is how many? Is 16 factors, okay? So are we done now? Are we going to answer a question that there are 16 factors and more than 3 factors? Of course not. We are not done yet. We have not considered anything about the number of factors among these factors. So the 16 factors actually represent that 2024, the number itself has 16 factors, okay? So we are going to see how many of these 16 factors have more than 3 factors. So this is what the problem is really asking for. Good. So let me change my color. I will just keep writing here, okay? So now, let's recall that we can always, more than 3 is 4 and above, right? 3 is not included. So how about, let's think about finding those factors that have less than or equal to 3 factors. Then we exclude those numbers from the 16 factors, which should give us the same result, exact result, as doing it in a straightforward direction, right? So number 3, our step 3 is first, let's think about number of 1 factors, okay? Number of 1 factor. So which number has only 1 factor? It's just 1, right? 1 is a factor of every integer, and 1 its only factor is 1. So number of 1 factor is 1, okay? Now let's think about number of 2 factors. So there's another name for number of 2 factors. What's the name? It's actually prime, right? Because prime number, its definition is just numbers that has the only factor to be 1 and itself. Okay, good. So what are the prime factors? We have it here. So these are prime factors since we performed the prime factorization, which are 2, 11, and 23. So just copy them here. 2, 11, and 23. These are prime, so they only have 2 factors, 1 and the number itself. Good. So let's think about the second case, third case, number of 3 factors, okay? Number of 3 factors. So we are talking about more than 3. So we need to exclude the 3 factor case. Which number has 3 factors? So here is a formula, okay? Remember that in the second step, we know the number of positive factors is just the exponent of each prime factor as 1, then times together. Now, number of 3 factors is basically saying x plus 1 equals 3, and x is the exponent. In this case, x plus 1 equals 3, so x is 2. We know that among those 2 to the third power, 11 to the first power, 20 to the 1st power, what is one possible case when we have the second power? It's just 2 to the second power, right? Which gives you 4. And this, you know that exponent is 2. So 2 plus 1, this should give you that it has how many factors? It has 2 plus 1, which is 3 factors, okay? We actually tested. We have 3 factors for the number 4. So for 4, 1 is a factor for sure, 4 is a factor for sure, and 2 is a factor, okay? So 4 has 3 factors. Now, let's exclude all these numbers from our total 16 factors, okay? 16 possibilities. So I will say exclude the above 5 numbers. That's 1, 2, 3, 4, 5, okay? So exclude the above 5 numbers. Good. Exclude the above 5 numbers from what? From our 16 factors. So that will give you 16 minus 5, which is how many? 11, okay? I will put a little box to denote that's our final answer. So which option are we choosing? Option D. Okay, very good. So you see, once you see a problem like this, it's asking for factors, so prime factorization is a must. And the second step is to apply the formula. Always remember the number of positive factors is equal to the exponent plus 1 of each of the prime factors, then multiply all these summation up, okay? The third step is basically case-by-case consideration. Okay, very good. Now, we are ready to see a real AMC problem testing you on this concept, this approach. So the question is asking for, okay, let me get my pen ready. So the question is asking for how many factors of 2020, okay, have more than 3 factors. Okay, let me rewrite that. Have more than 3 factors. Again, it gives you an example, but you know this one is really the same as last one, except we'll change the number from, I think, 2024 to 2020. So what's our first step? Prime factorization. Okay, very good. Okay, so already in blue. So I will say find those prime factors of 2020. So find prime factors of what number? 2020. Good. So is 2020 an even or odd number? It's even, right? So 2020 divided by 2 is 1,010. Divided by 2 again, since it's even number, okay, we have 505, 505, and 505. Take a look of the last digit. It's just 5, right? So any number that ends with 5 or 0 must be a multiple of 5. Good. So 505 divided by 5, we have 101. And although 101 is a 3-digit number, but actually it's prime, okay? It has only 2 factors, 1 and 101 itself. So in this case, I will just say 2020 is equal to 2, how many? Okay, 2 to the second power times 5 times 101. So again, okay, for our later convenience, I will put power of 1 on both these numbers. Good. That should be enough for our first step. Now, for the second step. Second step is just apply the formula. Apply formula for second step. Remember the number of positive factors. Number of positive factors of an integer. In this case, the integer is just 2020, okay? The number of positive factors of 2020 is equal to the exponent of all its prime factors plus 1. You get a sum, then multiply those sum together. So in this case, our exponent are 2, 1, and 1. So 2 plus 1 gives you the first multipliers times, okay, that's 1. You see why I'm writing 1 explicitly out? That will be very helpful, okay? So 1 plus 1. How about the last multiplier, okay? Exponent, which is 1. Don't forget a plus 1. So we have 3 plus 2 plus 2, which is 6 plus 2, right? It gives you 12 factors, okay? So 12 is the number of factors for 2020. Let's think about what should we do on the final step. So, okay, it's moving around, okay? So right here, let me zoom in a little bit, okay? Okay, good. So for our third step, okay, so the third step is what? Is to consider it case by case. Since it's asking for more than 3, and the total possibility is 12 factors, so we can exclude those factors that have less than 3 factors or exactly 3 factors, right? So first consider about number of 1 factor. So what is the number that only has 1 factor? It's just 1 itself, right? It cannot have any additional factor. So it's just 1. That's the easiest case. So number of 2 factors. This is also called what? Prime, right? It's being prime to have only 2 factors. So that will be 2, 5, 101. So remember, that's exactly the result from our prime factorization procedure. So that will give us 2, 5, and 11. Okay, very good. So think about number of 3 factors. We need to exclude that case as well because we're asking for strictly more than 3. So 3 cannot be included. So how to find those of 3 factors? Remember, the number of factors is determined by exponent plus 1 and multiplier, right? So since we now have 3, assume our exponent is x, we will have x plus 1 equals 3. So we need a prime number that has 2's power, has second, so it has a power of 2, has exponent of 2 to be a factor of 2020, right? What is that number? I think it's just 2 to the second power. Why? Because now exponent is 2. 2 plus 1 gives you 3, satisfy our restriction. So 2 to the second power is 4. And we know that this will have 3 factors, right? Because, okay, exponent is 2. So plus 1 will gives you, in total, 3 factors. Okay, so same idea, since asking for more than 3. So we're going to subtract those 5 cases, which is 1, 2, 5, 101, and 4 from our total 12 cases. So I will just write more than 3 factors, more than 3 factors. Okay, it's just 12 minus 5, which is how many? It's 7, okay? So where is 7 among our solutions? Okay, it's right here. So we are taking option B. In total, there are 7 factors of 220 that have more than 3 factors. Okay, you see, that's for how to solve problem like this when you encounter in the real exam, okay? Good. Now, before we head to the, I think the 5th problem of today's lab session, I would really like to give you a quick introduction about the textbook I'm using right now. Okay, so maybe if you came here early today, you know that before the live session starts, I will introduce about this book. This is indeed a wonderful book. First, all those problems I'm live streaming come from this book. Okay, so they are extracted from this book. And except those 100 tricky AMC problems, we also have 50 plus the most frequently tested modulus, including this book. So by having this book, you are going to know, okay, what is the most likely question that's going to appear on the real AMC exam, maybe in 2025. And besides that, another good part about the book is that instead of putting all questions in some random order, we now have all questions well organized into 6 modulus. So the 6 modulus are geometry, word problem, arithmetic, number theory, and also I think there are probability and statistic related material. Okay, so for example, if you get very close to the exam and you feel like I need some actual practice in geometry, I'm not very confident in geometry. Okay, you turn to the geometry page. For example, you can see right here. You can see these 2 pages. They are 4 problems listed, and they are all about geometry. So they will save you a lot of time, right? And another good thing about the book is that before you actually start doing any homework or any self practices, you can always see there's a summary in front, there's an example in front. So you can first go through the example to know, okay, I'm going to use this method right after it. And you can see what are the summary, what are the key points that you are going to be tested. So originally the retail price of this book is 59 US dollars. Now, okay, you have a chance to take it free, the exact same hard copy as I'm holding now. Okay, so how to have this book? First, if your child is a new student and never enrolled in our Think Academy long-term class curriculum, then you can add me using that WeChat on the bottom of the slides. So my WeChat ID is Think VIP 60. T is capitalized, VIP is capitalized, and there's no space in between. Okay, so you're welcome to add me on the WeChat, and I will try my best to help you register a class, a trial lesson that is fits your children's time and their study level the best. So the class is only $1, by the way. So after they finish the class, our customer service colleagues will deliver this book directly to your address as fast as possible. You do not need to pay for the shipping. Okay, so basically only $1. Finish the trial lesson, then you get the book. Now, if you are an existing customer of Think Academy, especially for grade 4 and grade 5, I believe that this book should be already shipped to you. If you haven't received it yet, it should be on their way to your home. Okay, and if you feel like I don't receive a tracking number or I'm being waiting too long until I get a book, you are also very welcome to add me using that WeChat ID ThinkVP60, and I will also try my best to help you secure your copy to make sure your copy delivered to your home on time. Okay, so there's only one restriction applied to this activity, is that it only applies to students who are going to be 3 to 4 to 5th graders after the summer break. That's for those students who are going to grade 4, grade 5, and grade 3. That's the senior grades of elementary school. Other than that, it's not going to participate in our activity. Okay, all right, good. So that's for the information session. Now let's get back to the problems. So exit ticket is going to test our understanding of the knowledge we just learned. For any positive integer m, the notation m with the symbol denotes the product of the integers from 1 through m. So as you go later, maybe into middle school or high school, you are going to know that this notation, it has a term, okay? It has a name that describes the calculation. So I will write it down here just for your information. It's called factorial. You can see the words factorial, it involves factors, right? Okay, good. So what is the largest integer n for which 5n is a factor of the sum? Okay, this is the sum. It's a factorial of 98, factorial of 99, add up, then add a factorial of 100. So, okay, we're still looking for the largest. let's do the first one. So since we are giving this summation of factorial, let's try to do some simplification to make it look better, okay? So I will write 98 factorial plus 99 factorial plus 100 factorial. I will copy it down. So 98 factorial, let's just copy that, okay, without changing anything. And think about what is the definition of factorial. So for example, 3 factorial is 3 times 2 times 1, and 2 factorial is just 2 times 1. So 3 factorial is actually times 3 to the 2 factorial. So same idea, 99 factorial is you times all the integers from 1 to 99. And 98 factorial is you times all the integers from 1 to 98. So the only difference between these two calculations is that 99 factorial, you multiply another additional number, which is 99 to the 98 factorial, okay? So that's the good part about factorial. You can always rewrite them into some number multiply another factorial. So that will help a lot when doing the calculation. So that will be 100 factorial. It's just 100 times 99 times 98 times 97. So the rest is basically 98 factorial. Good. Now let's highlight those terms that are shared by each of these three multipliers. Okay. So those are the 98 factorial. So let's apply the what? The distributive law. Okay. So our old friends already. So I will put 98 factorial outside of the bracket. So now it's actually multiplied by 1. So 1 plus here, left over is 99. And whatever left here should go to the bracket, which is 100 times 99. Very good. So let's calculate whatever is inside the bracket. 1 plus 99 is 100. We have 100 times 99. So this gives a total of 100 times 100, which is 10,000. Okay, be careful with all those zeros. So it's 98 factorial times 10,000. Good. So these are already two factors, and we're asking for what is the largest integer n for which is the exponent, right? Which 5n is the factor of the sum. So let's consider about these two multipliers, these two factors separately, okay? Case by case again. So I will say consider separately. Okay, how to spell separately? Okay, good. So that should be very enough for our first step. Now let's go to the second step, okay? So now for the second step, since we know that 5 is a prime number, okay, let's put it here. 5 is prime. Then we are going to apply another formula. So let's recall that when we want to figure out how many factors of 5 to its nth power we have for our summation of 98, 99, 100 factorial, we actually have this formula, okay? So I will say it's 98 over 5 plus 98 over 25, which is 5 to its second power, okay? Same symbol. And let's talk about this bracket thing. It's not actually not a bracket, but this means you divide 98 by 5 and you just consider about the quotient, okay? Consider about the quotient, not the remainder. So for example, 98 divided by 5, you should get how many? You should get 19, right? Because 19 times 5 will give you a remainder. But if you try 20 times 5, you will get 100. That's more than 98. So you can only use 19. 19 times 5 will give you the quotient. So here I will say that's 19 here, okay, with a remainder of 3. But in this case, we are not considering about the 3 as a remainder. And same idea, 98 divided by 25. And we're only taking care of the quotient, not the remainder. So 25 times 3 is 75. So the difference between 98 and 75 is 23, right? 23 is less than 25, less than the divisor. So that will be the remainder, and we do not care about the remainder. So the quotient is 3 times 25, so that's 3. We add them up. Okay, so actually someone will ask why is divided by 5, then divided by 25. So now we're looking for how many factors of 5 are we going to have, right? So factors of 5 can be factors of 5, or it can be factor of 25, since 25 is the second power of 5. You see? So this gives you 22. Okay, notice 22 here is what? It's the number of factors of 5. So are we done? Are we going to select 22? There's no 22 actually. So we are not done. Why? As I said, we are considering case by case. We now only consider case about 98 factorial. We are left with 10,000 to be considered. So that starts our second case. Okay, I will put as our third step actually. So, okay, sorry. So for the third step, 10,000. If I write it here, let's figure out how many factor of 5 to the nth power are included in this 10,000 number. So let's do 5 first. We're left with 2,000 and 5 again. With 400 our left over. Divided by 5, we get 80, still end with 0. So that should be a divider of, should be able to be divided perfectly by 5. 18 divided by 5 is 16. I mean, 16 not done yet. You can still say, okay, 16 is 2 to the fourth power. But remember, we only care about what powers of 5. So how many powers of 5 do we have? 1, 2, 3, 4. So we now have 4. Now I will just put here 10,000 has 4 factors of 5. Okay, very good. Now, remember, when talking about case by case, we always want to combine all the results from each case. So we have total to be 22, okay, from the 98 factorial plus from the 10,000, which is 4, okay, we have 22 here and 4 here. So 22 plus 4, what is their summation? It's just 26, okay? So A, B, C, D, E, what is the one we're looking for? 26 is option D. Okay, very good. So you can see this problem is not that straightforward. So that's why it's called a tricky problem. We are going to first understanding what is factorial, then do some simplification, okay? Then after that, it's going to test us if we know the formula, if we know the calculation that only cares about the quotient instead of remainder. Then we're also going to be tested on our case by case thinking ability. Okay, always think case by case when you feel like it's too complicated to consider everything for all cases at one time. So that's for the extra ticket. Now we are ready to do another warm up. Okay, so Lately equally distributed 140 pieces of candy into some piles. Okay, so let's highlight the keywords here. I will use blue. So this is our character, Lately. Then this word is important. Okay, even equally distributed 140 pieces of candy into some piles. The number of pieces of candy distributed to each pile is an odd number. So the question asking for how many ways are there to distribute the candy? So since we are talking about distribution of a large number, it's very naturally. Okay, let me pause a little bit. Okay, for now. So think we are talking about distributing a number into several piles. It should be very not naturally to think about what? To think about finding the factors, right? So the first step, as always, in number theory problems, we'll do factorization. So I will say perform prime factorization. Factorization. Okay, very good. So now our number we need to factorize is 140. So write it down here. Even number, odd number. End with 0, so no doubt it's an even number. Divided by 2, we get 70. Divided by 2 again, we get how many? 35. So 35 is the product of 5 and 7. So now we are done. Not that hard at all. 140 can be written as 2 to the second power times 5 times 7. Okay, good. So 2 to the second power, let's just write it here and write it here, okay? So as I said, you sometimes want to purposely write out the power of the number, even if it's just one's power, okay? So let me see if it's still live streaming. Okay, very good. Now, let's go to our second step. So I will get my pen ready. What's our second step? Okay, here is our second step. Let me zoom out a little. Okay, very good. So for the second step, I will start here with number 2. We're going to apply the formula. Which formula? Remember, in the previous problem, we know that when we want to find the number of positive factors, we are going to add 1 to all the exponents of our prime factors, then multiply those summations together, right? So, however, here, we're not looking for all positive factors. Sorry. We are looking for only what? Odd numbers. Okay, so that's our keyword. So we're going to say still apply the formula. And the only change, okay, we're going to make is that the number of odd factors is still adding 1 to the exponent. But in this case, exponent refers to those of odd numbers. For example, 2 to the second power. Is 2 odd number? No. So we are not going to use 2 as the power from an even number. We only care about odd numbers. So what are the odd numbers in our factorization procedure? It's this one, 5 and 7, right? So this will just be taking care of their exponent, and always remember add 1 to exponent, okay? So that's minor but important. Then we do the middle with a multiplication sign. Then that. Again, we only care about all numbers. So 2 to the second power, we're not adding 1 to 2 because the 2 is an even number, okay? So 1 plus 1 is just 2. Then 2 plus 2, okay, zoom in too much. So 2 plus 2 is 4. We know that. How many ways are we going to distribute the candy? We have in total 4 ways. So that will be 4. Okay, good. So after this, I think we are going to test another problem using the same idea. So I will keep the summary after our information session. Okay, so for this one, it's just 4 ways. Okay, so before we heading out to our last 2 problem of today's live stream, here is a brief introduction about the upcoming timeline for preparation for the 2025 AMC exam. So starting from June, starting from summer, okay, we have the first round of AMC 8 prepare with past exam lesson. So in this lesson, the highlight is that students are going to do real AMC problem with the teachers in each class. So every class will focus on 1 year of past AMC exam. For example, for the first round, we already have 2009 AMC exam explained, 2012 is done, and 2014 is done, okay? So you can see we are doing those past exams year by year, class by class. And office hours also included in this one. So this should be really beneficial for those who are trying to be more familiar with the format and style of problems before taking the exam, okay? So in August and in October, we're going to have modular class. So modular class is a class that focus specifically on only one module among those 6 modules in total. For example, let's say there's a child who is really good at all the rest 5 modules, but needs some help in number theory, okay? So then it's really beneficial for him or her to take the module class of number theory, so she or he can be balanced on all 6 modules. So that's the purpose of modular specific class. By the way, after our first round of our prepare from past exam AMCA lesson, we are also going to offer you the second round. So for the second round, it's going to be in the exact same style, same format, still go through real exam problems in each class session, but we're going to use different years problem. For example, in the first round, we have 2012, 2014 included. And in the second round, what year are we going to use? We are going to use 2013 and 2015 as our class contents, okay? So that's the idea of the prepare with past exam lesson. And you can see the barcodes already on the right-hand side of the screen. You are super welcome to scan that to know more about those two lessons. And as we go through the end of 2024, we're also going to offer you the AR class for 3 rounds and its counterparts, HR class for 3 rounds. So AR class is designed specifically for those who are aiming for the achievement role, okay? And for the HR lessons, those are specifically designed for those who are trying to get the honor roll. So honor roll HR class is going to be a little bit more challenging than the materials covered in the AR class, right? So HR class will basically focus more on the first, I'll say 18 to 22 problems, while AR class will majorly just do the first 12 to 18 problems. So that will be the major difference, the level of difficulty. So before we actually taking the exam in the January of next year, there are going to be one last DHR class. So from the name, you can tell that DHR is designed specifically for Distinguished Honor Roll. Okay, so they will be challenging, of course. And besides those class offered, we also have 5 rounds of mock exam. So those mock exams can give you a valuable opportunity to test your time management, to test your you will actually be timed, so it will test you on the time management and test your overall ability to see how many problems can you get cracked and how many problems can you get done before the time runs out. Okay, so that's a really good exercise before actually taking the exam. So in terms of a big picture, we have 2 rounds of prepare with past exam class, 2 rounds of modular class, 3 rounds of AR and HR class, and how many? 5 rounds of mock exam. So it's really up to you just to take the classes you feel like you are in need. I'm not saying you're going to take all those maybe 12 classes. Just take the class you feel it will be most beneficial, most rewarding, okay? So if you have any question about the content of the class, the format, or class material, or the timeline in general, you are super welcome to add me on my WeChat. So I post my WeChat ID at the bottom of this page, which is Think VIP 60. T is capitalized, VIP is capitalized, no space in between, okay? You can take a screenshot or write it down. I will pause for maybe 2 seconds. Okay, so that's my WeChat ID, and the barcode is for the prepare with past AMC exam lesson registration code. Okay, good. Now let's go to our last 2 problems. So in AMC 8, the question asking for how many positive factors does 23,232 have, okay? So actually, there's a quick, very fun fact of this number, 23232, if you read from left to right. And also, if you read from right to left, you will also have 23232. So a number like this is actually have a very special name. It's called a palindrome. We introduced the idea of palindrome in the previous live stream session. So the recording is up. You can always review that. Okay, review my lecture on the YouTube channel. Good. So for this question, positive factors. So what words are we seeing? Factors, right? So we are going to do prime factorization first, as always. So I will do the step 1 is perform prime factorization. Prime factorization. Okay, very good. So, okay, I will write it entirely. 23,232. Good. So let's copy the number here. Our first step is always, if it's even number, then try the divisor of 2, okay? So this number divided by 2 will give you 11,616. Still an even number, so divided by 2 again, you have 5,808. So that's a lot of division calculation, okay? 5,808 divided by 2. This will give you, I think, That's 2,904, right? You can test it yourself. Then 2,904 divided by 2, you will have how many? 1,452. Then continue, since we have 2 as the last digit, even number. 1,452 divided by 2 is going to have 7,052 divided by 2 is 26, okay? Then same deal, even number divided by 2. So that will give you 3,063, I think. So if you times 2 back, you will get 723. Okay, that's correct. So 363. How are we going to do that? 3 as 6 as 3. So these number adds up, can be divided by 3. Means that the number itself is a multiple of 3. Okay, always consider these tricks. If we add up the digit and they are multiple of 3, the number itself is a multiple of 3, guaranteed. So this number divided by 3, we're left with a 121. So 121, very quickly, that's just the square of 11, okay? We should be able to observe these numbers. So divided by 11, we have 11. 11 is a prime number, so our prime factorization can be terminated. Okay, good. So let's rewrite the expression of 23,232 into those factors. So how many 2's we have? 1, 2, 3, 4, 5, 6. Good. So that 2 to its 6th power times, there's only 1 3, but we have 2 11. So 11 to its 2nd power. Okay, very good. You see, I'm writing down all the power, even if it's just 1. Okay, I'm still writing out explicitly. That should be good for the first step. So let's see what's our next step. I will use arrows. Okay, so it's asking for how many positive factors. Remember that this is a step of applying the formula. Okay, so I will say apply formula here. The number of positive factors of integer, number of positive factors of an integer is equals to all the exponent of the prime factors add 1. Then we find the product of their multiplication. So number of positive integers of our number is 23,232. It's just equals to what is our first exponent. That's 6 plus 1. Don't forget the plus 1, okay? Then what is the exponent of our second prime factor? That's 1, okay? So just 1 plus 1. So 6 is here, 1 is here, and 2 is here. Then times 2 plus 1, okay? So that's 7 times 2, which gives you 14 times 3. What is our final answer? 14 times 3, okay, is 42. Good. So these give you the total number of positive factors. So where is 42? It's option E. So you see, just 2 easy steps. First step is prime factorization. Second step is apply the formula. Know the number of positive factors. Okay, good. So we're going to do the exact same thing on our last problem of today's live session. It's an exit ticket problem. So how many positive factors? Even easier than the previous one, I think. So I think there's a problem asking for all factors. We need to distinguish, okay, which prime factor is odd and which is even. But this one, we just add up all the exponent plus 1. Multiply up all the exponent plus 1, right? It's even more straightforward. Okay, good. So I will do step 1, perform prime factorization. Perform prime factorization of what number? On this 21,600 number. Okay, that's a large number. Let's be careful. So start with 2, since it's a prime number. Okay, let me write it better. Since it's an even number, I'm sorry, I'm making an oral mistake. So that's 21,600 divided by 2. It gives you 10,800 as our result. So divide by 2 again, we should have 5,400, okay? Okay, 5,200 divided by 2 again. We should have, okay, let me change my pen. pen really quick. Okay, so that's color gray. So we should have 2 for here. 5,400 divided by 2 will give you 2,500. Divided by 2, we are going to have 1,350. Good. Divided by 2, once again, you have 675. Okay, so this number ends with what? Ends with 5. So it's guaranteed to be a multiplier, to be a multiple of 5. So 675 divided by 5 is 1,000, and it's 135 divided by 5 once again, because the last digit is 5. You will get 27. Now let me go up a little bit. So 27, obviously, divided by 3, left with 9, divided by 3, one last time. You have a prime number 3 right here. So finish with a prime number. We know we can terminate the factorization process. Good. So, sorry, let's rewrite the number. So that's 21,600. It's equal to 1, 2, 3, 4, 5. 2 to its fifth power times 1, 2. So 5 to its second power times 1, 2, 3. Good. 3 to its third power. So let's keep those exponents carefully, okay? We're going to make use of them. So what's our second step? I will change another color. How about yellow? So our second step, which follow right here, is what? Okay, it's apply the formula, okay? Apply the formula. So we use this formula a lot of time. We should be very proficient with it right now. The number of positive factors, right? It's on the prompt. Positive factors of which number we have it now? 21,600 is just equals to what? First, identify all the power, all the exponent, okay? So all the exponents supposed to be plus 1, then find their product doing the multiplication. So the exponents are 5, 2, and 3. So add 1 to each of them. We will get 6, comes from 5 plus 1, times 3 comes from 2 plus 1, and times 4 from 3 plus 1. Good. So that's basically 18 times 4. So that will give you a product of 72. So where is 72? It's option D. Okay, good. For now, I think we should be very proficient with the formula, and I do not need to explain this once again, right? Just be careful with exponent. Then don't forget about the add 1. Okay, good. So that will be very enough for the last problem. And quick information session before we end today's live stream. So as you guys can see, I'm holding a very thick AMCA book in my hands, and all the problem that I explained in today's live stream, they are directly from this book. There is a session called 100 AMCA tricky problems at the back of the book, I believe. And besides those 100 tricky AMCA problems, those are good resources for test preparation, right? So besides that, we also have 50 plus most frequently tested knowledge points in this book, detailedly explained one by one. So having this book means that you are having a very good resources that can help you to know, okay, what is the style of problems the AMC8 are likely to have in the exam, and what is the format, what is the knowledge they're trying to test me, okay? So after knowing all this, there is no way to get well prepared. And before I move on to the next part, I also want to mention about, let's say you can turn to, for example, this page. So as you can see, we are having problems grouped into Warmup, in AMC8, and exit ticket. So you can see also from today's live stream, these problems test you on the exact same idea or concept, but they are challenging and more challenging, right? So AMC8 real problem is more challenging than the Warmup, and the exit ticket, the final test, is more challenging than the AMC8 real problem. So that's the point, because you first get familiar with a concept, then you're trying to apply that, then you're trying to apply in a more complicated scenario. So this will help you to, I would say it's really beneficial for self-learners, right? You can actually teach yourself. So that's a good point as well. And also this book is carefully designed into 6 modules. That's for geometry, word problem, arithmetic, probability, and statistics. Also for today, number theory, right? So it's not like randomly put problems into one thick book. So you can actually quickly turn to, for example, geometry. So you can quickly turn to geometry and see, for example, this page, all 4 problems are geometry specific, right? So that's very good for test preparation as well, as you can focus on your weakness and save more time. So this book original is retailing price is $50, $59 USD. Okay, now you can get a free hard copy, this exact same one I'm holding right now, I'm using right now. So how to get that? There's 2 ways. The first way, if your child, if the student is a new student to our Think Academy, then you can add me on the WeChat, which is ThinkVIP60, right on the bottom of this slide. Okay, you can add me on the WeChat, and I will get to you as soon as I can, so I can help you to register a trial lesson only for $1 that suits your children's time and it fits your children's current learning level. Okay, so when we get the 12 lesson set up and the student finish the 12 lesson, this book will be sent out by my customer service colleagues to your home as fast as possible, and no need for paying the delivery fee or shipping fee. Okay, that's for free. Finish the $1 trial class, you get a free book like this. Okay, that's a good deal, right? How can I turn this down? And for existing customers that we already have, especially for those grade 4 and grade 5 competition class students, I believe that this book should be already with you right now. It should be already sent out. And if you have trouble getting your book, or you want to have a tracking link, you can also add me on the WeChat, ThinkVIP60, the same ID. I will try my best to help you get yours, okay? So finally, there's one restriction on this activity, one small restriction. So this activity only applies to those students who are going to enroll in grade 3, grade 4, grade 5. That's basically those senior grades in elementary school after the summer break. So for example, if you are in the lower elementary school, your child is in the lower elementary school, then it's a pity that this activity doesn't apply, okay? So that should be all for today's live stream. Again, thank you so much for coming, and I will wish you a good rest of the day, all right? I will see you next time. Bye.